Dear students, welcome to the next session of wave optics, part 5, diffraction and polarization of light. Let us start now. The first question: a slit of width A is illuminated by a white light. For red light, lambda is equal to 6500 angstrom. The first minima is obtained at theta is equal to 30 degree. Then the value of A will be. So here, what are the provided things? The provided things are theta is provided and the red light wavelength. So using this we have to find the answer. Here the answer is third one, 1.24 microns. Let us see how. For the first minima, theta is equal to lambda by A. Theta is equal to lambda by A. And theta equal to 30 degree. Okay. So it is in degree measurements. It is in degree measurements. Theta is equal to 30 degree measurements. So we need to change in radian measurements. So 30 degree equal to 30 into 5 by 180. So we will get this will be go to 6 times. So pi by 6. So once we substitute the values here, lambda, that is 6500 into 10 raised to minus 8 centimeter into, that is A. We already changed this. A is equal to lambda by theta. A is equal to lambda by theta. Theta is equal to lambda by A means this is we interchange a simple mathematics. So A is equal to lambda by theta, that is lambda into 10 to the power of minus 8 centimeter divided by pi by 6. Pi by 6 means divided by pi by means 6 by 5 multiplication. So this will be 1.24. After simplification we will get 1.24 into 10 raised to minus 4 centimeter. This 10 to the power of minus 4 centimeter is a micron. So it is 1.24 microns. Okay, so that is the value here. So the answer is 3. Okay, let us go to the next question. A yellow light is used in a single slit diffraction experiment with a slit width 0.6 mm. If yellow light is replaced by X-rays, then the pattern will be here. What is mentioned here? Yellow light is used for a single diffraction experiment. And the width is 0.6 mm. And this yellow light is replaced with X-rays. Then the pattern, what will be the pattern? So here diffraction is obtained when a slit width is of the order of wavelength of EM waves or light, electromagnetic waves. See here, the X-ray actually its wavelength is very low, means slit. Okay, this is the slit width. Okay, let us see. The slit width is 0.6 mm. That is D equal to 0.6 mm. And the yellow light in this single slit is yellow light is passing through this one. Instead of that one, we make it a X-ray light here. This X-ray wavelength is very less, so the wavelength is very less, so it will easily pass through the slit, so there will not be any diffraction happen. When compared to the yellow light, the slit width of the order of the wavelength of the light and the X-ray lights are very lesser. Here X-ray lights, actually its wavelength is 1 to 100 angstrom. It is very lesser than the slit width of 0.6. So it is 0.6 mm is a this distance. The wavelength is very less, means it will very without, when we compare in this one, it is very less, so it directly passing through this. There will not be any diffraction, there will not be any diffraction pattern. So that means second question, the second one is the answer. Okay, no diffraction pattern. And let us see the third one. Here a beam of light of wavelength 600 nanometer from a distant source falls on a single slit 1 mm wide, and the resulting diffraction pattern is observed on a screen 2 meters away. The distance between the first dark fringe on either side of the central bright fringe. Here you can see, let us see here, see this our screen is this one, okay, and this is the this is the slit width. This is the slit width, and rays are going like this. So here slit width d equal to 1 mm slit width, and the distance from here to here is 2 meter. Okay, and the first fringe here, see here this point, let us take it as A, and this point O. So it is like this. So here this is the angle theta. So consider this OA. Similarly here the next one will be here. So this is B. Suppose this is B. What we need to find out is the distance between A and B. What is the distance? This we have to find either side of the bright fringe. So as you know, here d sine, we have an equation d sine theta equal to n lambda, and for theta is very small, if the theta is very small, then sine theta equal to theta. For small theta, that means this theta comes to very small here, then the sine theta, you know, opposite side by hypotenuse. This is D, this point to A is the hypotenuse. So here opposite is OA divided by OA divided by, suppose this is D, AD. See, if small angle theta, this is, if it is theta is very small, then this AD becomes OD. And this OA is OA. Okay, this OD we can take, we know this distance is 2 meter. So this is OA divided by 2 meter. Sorry, 2 meter. It is provided to 2 meter. Okay, and let us take this one as x. So it is x by 2 meter. That is sine theta. Okay, then d x by d equal to n lambda. That is d sin theta is equal to here x by d. That this d is equal to d sin theta is equal to n lambda. D sin theta is equal to n lambda. Here what I did is d sin theta is equal to d sin theta equal to n lambda, and this sin theta d into sin theta we already x by 2 means x by d into x by 2 meter is equal to n lambda, and x equal to n lambda into 2 by d. What is d? D here, d is provided 0.1 mm, that is 1 into 10 to the power of -3 meter. So that is here n is for one first fringe. For both it will be 2, so it will be n is equal to 2 into 600 nanometer, that is 10 to the power of -6 divided by 10 to the power of -3. That's equal to, after simplification we will get 2.4 mm. I hope you clear this one. If you did not understand, just send a message to me, then I'll explain it again. So this is the answer, 2.4. Okay, so let us move to the next question. Question number 4. The diffraction is obtained by using a beam of red light. What will happen if the red light is replaced by the blue light? Here the question is, we are changing the red light to the blue light. What will happen in the diffraction fringe width? So the band will narrower or crowd full together, or bands become broader and further apart. No change will take place, bands disappear. The bands is the fringe. So let us see the answer. The answer is 1, that is bandwidth is narrower and crowd full together. See how we can find the answer here. We know the fringe width beta equal to lambda d, capital D, by small d. distance, and the small d is the slit width. Okay, so in this case here we are using red light and blue light. So what will happen, what the change will happen, because there is no change in distance and the of the screen and the slit width. So both these variables, both parameters are not varying, means only the varying thing is lambda. So fringe width beta is directly proportional to lambda, bandwidth of the light, and that will be depends on which light is using, so blue light or red light. So bandwidth of blue light, blue, and bandwidth of red light, red. So here electromagnetic spectrum, you can see the bandwidth of blue is less than the bandwidth of red. So that means bandwidth of B is less than the bandwidth of R. So the ratio of bandwidth beta 1 by beta 2 is equal to lambda 1 by lambda 2, lambda 1 by lambda 2. So here bandwidth for the red color is beta R and beta blue for blue color, and so the bandwidth is R, lambda R divided by lambda B. So means lambda R is greater than lambda B. Here lambda R is greater than lambda B, means this is greater than 1, greater than 1. So that means bandwidth for beta is less, so the blue light diffraction bands become narrower and crowded together. See here, this bandwidth is of the light blue is less than the bandwidth of red, so the fringe width is close together, maximum close. Blue light comes together and make it narrower, and the fringe, see the fringe width, if the fringe is come to crowded together and narrower, so the answer is bandwidth, bands will narrower and crowded full together, so the answer is 1. Then let us go to the next question. Question number 5. When an unpolarized light of intensity I0 is incident on a polarizing sheet, the intensity of the light which does not get transmitted is. Here the intensity of a normal light I equal to I0 cos square theta, where theta is the angle of polarization, and actually the intensity of polarized light, the light is half of the light is reflected, I mean not transmitted. So the intensity of the light not getting transmitted is I0 minus I0 by 2, that's equal to I0 by 2. So the half of the intensity, it is changed to half of the intensity. If an unpolarized light is converted into plane polarized light by passing through a Polaroid, its intensity becomes half. That means I0 minus I0 by 2 equal to I0 by 2. That means half of the intensity. So the answer is 3. Okay. So in this section of video I included only 5 questions. So next video I will make some more exercises and problem solving. So thank you for watching.